Okay, assalamualaikum and hello guys. So in this video I will discuss tutorial questions from chapter 1.1. So please do check your answers. Okay, so let's start with question number 1. They ask you to sketch y1 and y2, show that there is only one real root for this function. Okay, so obviously you gotta use the graphical method because you need to draw the graph diags. So we have the function 1 over x minus ln negative x minus 3. Okay, so obviously you cannot directly draw this graph. That's why you need to separate it. Ln negative x negative 3. So this is your y1. Sorry, this is your y2. And this is your y1. Okay, so basically you are using the graphical method. The second part, which is you need to draw two different graphs and check whether they have points of intersection between the two graphs. Okay, so now let's draw our graph. So the y2, we have reciprocal function or rational function. So this is a very basic function, so you must remember how to draw it. So this is the graph. Okay, you have vertical and horizontal asymptote, which is the y and x axis, so it cannot touch the axis. Okay, so this is your reciprocal graph. Okay, so now let's draw the ln function. So first we need to know the basic shape first. As you can see that the function inside has x, negative x. So the basic shape kind of looks like this, something like this, and it kind of has vertical asymptote that you have to find, VA, vertical asymptote. So how do you find it? Just simply equal the function inside equal to 0. So you're gonna get the VA. So x equal to negative 3. Okay, so let's draw the vertical asymptote first, somewhere over here. So this is x equal to negative 3. So I'm gonna make a dot line for the asymptote. Okay, so the graph gonna looks like this. Okay, so this is your y1. Okay, done. So you can label your function. Okay, so now let's check whether we have intersection between the two graphs. As you can see, there is one intersection over here. Okay, over there. So since there is intersection, as you can read from the notes, the roots are the points of intersection. So you have one intersection, meaning you have one root. Okay, so you can conclude as below. Okay, since there is one intersection, there is only one root for the function. Okay, done. Okay, number 2, show that there is a root lies between negative 1 and 0 for the function by using algebraic method. Okay, so algebraic method is simple, as you just need to substitute the value of two values and check whether they have different sign or not. Okay, so first I substitute negative 1, so become negative 1 square minus ln 2 negative 1 plus 3. You're gonna get 1, and then for the 0 square minus ln 2 multiplied 0 plus 3, you're gonna get negative ln 3. Okay, so as you can see, the first value negative 1, you get 1 which is greater than 0, and then for the second value 0, you get negative ln 3 which is a negative number. So there is change of sign. So based on the formula, based on the notes, you can see that they say the two values a and b such that fa and fb have different sign. So if there is different sign, meaning there is a root between the two value. Okay, so you can conclude like this. Okay, since there is change in sign, there is one root lies between the two value, which is in this case negative 1 and 0. Okay, okay, moving on to number 3. By sketching the graph fx and gx, show that the equation below has one root, hence solve the equation. Okay, so this is also same as number 1. You just need to rearrange the equation, okay, because we cannot directly draw the graph. So negative 1 minus x. Okay, so this is your fx and ln x is your gx. Okay, so let's draw our graph. So ln x is also basic shape. It gonna looks like this with vertical asymptote x equal to 0. So this is x equal to 0. Okay, so you can find the intercept over here. So this is your gx ln x. So you can find the x-intercept. So x-intercept for gx. X-intercept is when y or gx equal to 0. Okay, so y equal to 0. So 0 equal to ln x. E0 equal to e ln x. So 1 equal to x. Okay, so here is 1. Okay, x equal to 1. Okay, for fx, you have absolute function, so you're gonna need to know the basic shape first. So you see the negative sign at the front, so meaning it has this shape, okay, the inverted V. Okay, so you need to find the point, the maximum point. So since there's nothing at the back, you're gonna have 0y. So for the x value, you just need to equal the function inside equal to 0. So 1 minus x is 0, negative x is equal to negative 1, so x is 1. So your y is 1. Okay, so you just need to plot. So 1, 0 is over here, so your graph gonna looks like this. Oh, sorry. Like this. Okay, so this is your fx. Okay, now we need to check whether it has intersection or not. So yes, it does. It is here at x equal to 1. Okay, so this is intersection of the two graphs. Okay, so we can conclude over here, since there is one intersection, there is only one root for the function. Okay, now we have settled the first part. So it has second part of the question, which it asks you to hand solve. Okay, so this question actually want you to find the solution for this equation. Okay, find the answer for this equation, find the solution. Okay, so what is the answer or what is the solution for this equation? Your intersection, that is your answer, which is x equal to 1. Okay, x equal to 1, the intersection is the answer for this equation. Okay, so this is your final answer. Alright. Okay, number 4 is also simple because you can directly use the algebraic method. Okay, so you need to substitute value of two value which already given. Okay, and then substitute h2 and check the two values that you get whether they have different sign or not, and then you can make a conclusion. Okay, since there is change in sign, there is one root lies between the interval 1 and 2. Okay, and then for the last one, so by using either graphical or algebraic method, show that there is a root lies in the interval 0.5 until 1 for the equation. Okay, so I'll show you both, but you just need to use either one, either graphical or algebraic. Okay, so for algebraic method, it is simple because you just need to substitute the two value given over here. Okay, so you let your fx equal to ln x plus x. So you just need to substitute 0.5 and then substitute value 1. Okay, and check whether they have different sign or not. And if yes, then you can conclude like this. Okay, that is for algebraic method. So for graphical method, also same as previous one. So you have this function, and obviously you cannot draw this one, right? So you need to separate the two functions. So now you have fx, and then you have gx over here. Okay, so ln x is like this. We have drawn this before, and then gx is like this. Okay, basic linear graph. We have gx over here. Okay, so here is 1. So we need to check the intersection. So we do have intersection. It is here. Okay. Alright. So as you can see, we need to check if there is intersection between 0.5 and 1. So its axis 0.5 is somewhere over here, and this is 1. So yes, there is intersection between the interval. Okay. So you can just conclude like this. Okay. Alright, so we're done for the 1.1 tutorial question. Okay, so now let's continue with tutorial 1.2. So before that, let's recall the steps for Newton-Raphson. Okay, so first make sure you have the function fx and the derivative function. Second one, make sure you have the first approximation of value. So whether the question gives you the value or you need to find by your own. And then third step, or the final step, is to use the Newton-Raphson formula. Okay, so there are two important things that you have to remember. The first one is make sure to show the first two steps for substitution using this formula. You need to show the first two steps. Okay, it is compulsory. And the second one, make sure that you have one extra decimal place before you finalize the answer. Okay, so now let's continue with the tutorial question. Okay, so number 6, find the root of x plus 1x minus 5 equal to 0 by taking 3.5 as the first approximation. Okay, so we already know this is your x naught. Okay, and since the question doesn't tell you how many decimal places that they want, so you just need to decide whether 3 or 4. So let's choose 4. Okay, let's decide to choose 3 decimal place as the final answer. Okay, So now let's do step by step. Okay, so number 1, you need to have your fx. Okay, so since the right hand side already becomes 0, so this is your fx. Okay, you can let your fx become x plus ln x minus 5. Okay, and then find the derivative, so you need to differentiate, become 1 plus 1 over x. Okay, and then for the second step, you have the first approximation, which is 3.5. Okay, and then for the third step, you just need to insert into the formula. So based on the formula, it is xn minus fxn divided by the derivative. So it's going to become xn minus xn plus ln xn minus 5 divided by 1 plus 1 over xn. Okay, so this is the formula for this question. Okay, so now we just need to substitute the value. So your x0 is 3.5. So remember, you have to show the first 2 steps. Okay, substitution for the first 2 steps. So you just, for the x1, you substitute x0 into your equation, and then you get this value. And then for x2, you just need to substitute the value, the previous value you get, which is this one, this one, this one, this one, and you get the next value. Okay, actually from the video, you know that you don't need to calculate one by one. You just can directly use the calculator. Okay, so as you can see over here, I have 4 decimal place. I take 4 decimal place. Why? Because we need 3 decimal place as our final answer, so make sure we have 1 extra decimal place, right? So that's why I have 4 decimal place over here. Okay, so for the x3 and so on, you don't need to substitute one by one like this, no need. So you just need the answer. Okay, so you need the answer, you write the answer over here, and you can see it is exactly the same. Okay, so this is when you know you have to stop the steps. You need to stop the iteration. Okay, so when you stop, this is not your final answer yet. You need to round off to 3 decimal place. So this is your final answer. Okay, alright, so moving on to next question. So find approximation value for this, taking x equal to 1.9 as your first approximation. So again, you already know your x0, so this is your x0. So the question asks you to give your final answer in 3 decimal place. Okay, so make sure that your working steps have 4 decimal place. Okay, so now we do step by step again. So the first one, you need to find your fx. Okay, so since they don't give you the fx, you need to find your by your own. So they give you this value, so this is x actually. Okay, so x equal to cube root of 11. Okay, so now we rearrange, we cube both sides, so the left hand side become 3, this one become 10, and then we need to find the fx, so we need to bring all to the other side. So let's bring 10 to the other side, so the right hand side becomes 0. So this is your fx. Okay, so fx equal to x cubed minus 11, so differentiate, become 3x squared. Okay, so your second step, you have the first approximation value, which is 1.9. Okay, so you can just proceed to step 3, insert into the formula. So xn plus 1 equal to xn minus xn cubed minus 11 divided by 3xn squared. Okay, so this is the formula for this question. Okay, same as before, you already have your x0. So next, for x1, substitute x0 into the equation. Okay, 1.9, 1.9, 1.9, and you get this value. Make sure you have 4 decimal places because the final answer needs to be in 3 decimal places. Okay, so show the first 2 steps. Okay, and then keep going on until you get the same value. So when you get the same value as the previous x, then you know you need to stop. Okay, so the final value is this one, 4 decimal places. So you need to round up to 3 decimal places as your final answer. Okay, that is number 7. Okay, now moving on to number 8. So number 8, we have our gx over there. So we already know the first step. So the first step, your gx, sine x minus x plus 0.5. Okay, so you need to find the g prime x. So differentiate sine x is cos x, then minus 1. Okay, so second step, to make sure you have your x0, so it is given 1.5. Okay, so this is your third step. So let's check how many decimal places they want. They want 3. So make sure your working step has 4 decimal places. Okay, so this is the next step that you have to follow. Okay, so the last one is number 9. So by taking x equal to 2 as the first approximation, so this is your x naught. So evaluate this value. Okay, so this is same as number 7. So the first one you have to find your fx. Okay, so you don't have your fx, you just have a value. So this is your x. Okay, and then we cube both sides, so it becomes x cubed equal to 7. So bring everything to one side to make sure that the other side is 0. So this is your fx. Okay, so your fx is x cubed minus 7. So your f prime x is 3x squared. Okay, so second step, you already have the first approximation, which is 2. So you can proceed with the third step. Okay, insert the value and then stop when you get the same value. Okay, and final answer, make sure you round off to the required decimal places or significant figures. So in this case, they want 3 significant figures, which is 1, 2, 3. So the steps before, you need to have 4 significant figures. Okay, so that's it. Alright, so that's it for tutorial chapter 1. Bye guys.